Hello, everyone, and welcome to the next part of the introduction to limits. Before I proceed, I forgot to put the references, which is this one, animating and graphing second line in Desmos. If ever you want to graph something, just like what I did last time in the video, use this one. All right. Actually, I put it on a description, but it would be better if I'm going to show it to you because I know that there are some people out there or viewers who would rather just watching the video instead of just looking at the description. All right. So without further ado, let's now begin. So far we know about graphing, right? Now, how about algebraically speaking? Like algebraically speaking, can you? The answer is, I do not know. So let's just say we have a given function. Okay. Now here's the thing. This one, if you recall your, what do you call this one? Your lessons in functions, you will understand the notation of this. Okay. Now here's the thing. Let's try to have some recall to be particular evaluation of functions. So let's just say if my x here is 6, what would be your function here? So you're going to substitute your 6 to your input or to your x. So you have 6 squared minus 16 all over 6 minus 4. So 6 squared minus 16 is 64 minus 16 all over 6 minus 4. So to simplify further, oh, no. Wait. Since when it's 64? Wait, forgive me. It's a, it's actually 36. Forgive me, it's 36. Oh my God. Anyways, yeah, 36 minus 16 is, that's 0. 20. 6 minus 4 is 2. So the answer is 10. So f of 6 is equal to 10. All right, not bad. Let's have one more. Let's just say if I have negative 1. Forgive me. So let's proceed. So yeah, if we have negative 1, what will be the answer? So let's substitute negative 1 squared minus 16 all over negative 1 minus 4. So here you have 1 minus 16 all over negative 5, right? So here you will have 17. Oh, no, not 17. No, not 17. You will have negative 15 because 1 minus 16 is negative 15 all over negative 5. So this is positive 3. Oh, that's it. Now, how about if we substitute 4? So we will have 4 squared minus 16 all over 4 minus 4. So 4 squared is 16 minus 16, and we have 4 minus 4. I think we will know what will happen here. We will have 0 all over 0, which is, again, undefined. So, nope. It's impossible. It's impossible for you to find the value of this 4. Okay? But let's just say, let's give it a chance. Okay? Maybe not exactly, but how about in another way? In another way. Okay. Let's just say we will have a what I call this one? An evaluation. Now, let's have your x values, then of course the result, your f of x. Let's get say this. Let's get values that are 4. Okay. Let's first side. Okay, left side. Okay. So x on the left. Okay, on the left side. I mean from the left side. Okay. Let's get x values that are closer to the 4, but from the left side. Well, let's try 3. Okay. Substitute 3 in this function. Let's use our calculator. So we have third minus 16 all over 3 minus 4. We have, right, 7 as the answer. Well, how about 3.9? Because it's close to 4, right? 3.9 is close to 4. So let's substitute. Okay. So we use our input as 3.9. Hold on. 3.9. There you go. The answer is 7.9. Okay. Now let's make it even closer. So let's just say 3.99. Let's try that. So 3.99. 3.99. Hold on. 3.99. So you will have 7.99. Whoa. Okay. Now let's make it even more closer to 4. So 3.999. So what will be the answer here? So from the calculator, it's 7.999. Now let's do it again, but make it even more closer. So 3.9999. So here I can see the pattern, but I'll use my calculator. So this is 7.9999. Okay, and so on and so forth. Okay, so what can you observe? So as you let x values closer to 4 from the left side, what will be the result? Okay, as we let x values closer to 4, like as in closer to the 4, what will be the result you will have? 7.9999, right? But approximately, what is the result here? Approximately, you will have what? As you let x values closer to 4, what is the answer here? You know, approximately. It is approximately 8, right? You notice here, right? If you substitute x values that are closer to 4 from the left side, then the results are this. So we can conclude that it's approaching to 8, right? It's approaching to 8. You get me? Now here's the thing. What if we go on the right side? Okay, let's try on the right side. Okay, right side. So we will use x values from the right side that is approaching to the 4. So what are numbers that are closer to 4? 5, right? Because 5 is closer to 4. So substitute 5 in that function, you will have what? So 5 squared minus 16 all over 5 minus 4. So you will have 9, right? 9. Wait, am I right? 5, wait, 5 squared minus 16, 5 minus 4. Okay, good. Now, let's make it closer to 4. So let's say 5.1, right? 5.1. So 5.1 will give you this 9.1. Okay, 9.1. Now, the same way what we did earlier, let's make it even closer to x. Sorry, to 4. So 5.01. So in my calculator, it is 9.01. All right. Wait, you sure it's 9? You sure? Wait, let me just check. Okay, maybe I could be wrong. Okay. Last time we have wait. Hold on. I'm just making sure. Hold on. Let me just check. Okay, correct. Yeah, actually we're correct. You know, we're correct. Too bit far, I guess, because it seems like we're not approaching to the, to the 4. We're actually going far to the 4. So no. Sorry guys. It's not 5.01 or 5.1 because we are actually not approaching 4. We're actually approaching 6. You know what I mean? Or maybe we're approaching to 5 only. You understand? So we should be using values that are closer to 4. Okay? Forgive me. Okay? Let's try 4.9. 4.9 is close to 4. Okay? 4.9 is close to 4. So let's substitute. Let's substitute this one. 4.9. Okay, so we will have this answer, which is 8.9. Okay, it's 8.9. All right. Now, let's make it. Wait a minute. Am I really doing it wrong? I mean, yeah, it's actually correct. Yeah. How about we make it 4.5? How about that? So 4.5? Yeah, sure. The result here. The result here is basically 8.5. Yeah, it becomes 8.5 something. Okay. So now let's make it, I think let's choose numbers that are very, very close to 4. 4.1. Yeah, much better. 4.1. There you go. 4.1. Okay. 4.1. So let's substitute 4.1. Sorry, guys. I think I'm going too very far. So I think I'll pick numbers that are very close to 4. So 4.1. So 4.1, you will reach 8.1. So if I use 4.01, so my calculator, it is 8.01. How about this one? 4.001. So here I have 8.001. So let's do it even more closer to 4. 4.0001. So the answer here is 8.0001. Let's make it even more closer. 4.00001. The result will be 8.00001. So as we let our x values closer to 4, which in fact we reach, I think, until 4.00001, what's the answer here? It's 8.00001, right? But you know, in approximately, this is what? Approximately, this is what? 8. So as we let our x values from the right side going closer to 4, it approaches to approximately 8. What can we say? On the left side, it's approaching to 8. On the right side, it is also approaching to 8. So that means if we substitute 4 here, which would, wait. If we substitute numbers that are very close to 4, the result would be approximately 8. Okay? So exactly, if you use 4 here, it would be what? Undefined, right? It's undefined. But if you use numbers that are closer to 4, it is approaching to 8. So therefore, this one will be changed into this. Okay? Or it would look like this way. So if we substitute 4 here, the answer is undefined. But if we use this notation, the answer is 8. That's the answer. Okay? So what is this? What is this notation? Okay? What is this lim something whatsoever? Okay? What is this? All right? So let me explain it on the other side. Having x as 4 will result to an undefined answer. But if we use numbers that are extremely close to 4, it resulted to what? It resulted to approximately 8. Okay? Approximately 8. Okay? Therefore, as x approaches 4, it gets closer to 8. We can simply conclude that 4 is our answer since it is invalid. Instead, we will use limits. Okay? Okay, we will use limits. So the limit of function as x approaches 4 is 8. Or in here, we can pronounce this as the limit of x squared minus 16 all over x minus 4 as x approaches 4 is 8. So just like this. So in simple words, Matas Fan stated that it is a special way of saying ignoring what happens when we get there, but as we get closer and closer, the answer gets closer and closer to 8. All right? All right? So this one, in other words, is just like this. Okay? Like, I don't care what is the exact answer, like what is exactly is gonna what is the exact exact result of it. Like, I don't care. What I care about is as we get closer, what value is it approaching? Okay, so that is about limits. Limit is not about what is the exact answer when we substitute this that. No. Limits is about as we get closer and closer, at what value is it approaching? You get me? Just like this one. I don't care if I substitute 4 here, that would result to undefined. Okay, I don't care. But as we get the x values closer to 4, like 3.99999, and here, what's here? 4.000001. That's what I care. That's it. As we let our x values closer to 4, the value that is approaching is approximately 8. So that is limits. Okay, so we will learn more about limits, like how to use this limit, how to do this, what are the rules behind it. We will. For now, you get the idea. And that is all for the introduction to limits.